Today I will be talking about the substitution rule from section 4.5 of our textbook. Okay, so another name for the substitution rule is U substitution, and it's called this because we change an original x variable of a complicated integral with a new variable u, thus creating a more simple integral. So here I have an example of the integral of 2x times square root of 1 plus x squared dx equals the integral of square root of 1 plus x squared times 2x dx, which finally equals the integral of square root of u du. So we replaced all of the x variables with u variables. And this method works when we have an integral that could be written in this form: the integral of f of g of x times g prime of x dx. Okay, so next I will be talking about the important points of U substitution form. So here we have the U substitution form, the integral of f of g of x times g prime of x dx. And it's almost always certain that the U substitution form will have gx and its derivative g prime of x. And then also notice that if u equals g of x, then g prime of x, then du equals g prime of x dx. So you can think of du and dx as differentials from one another. One final thing I wanted to discuss before showing an example on how to solve an integral is using an integral using u substitution is finding what to set equal to u. So we have the integral of x times square root of 2x plus 1 dx. So usually you want to set u equal to the longer x expression that appears in the integral, along with whatever is inside another function. So we have 2x plus 1 as the longer x expression, and it's also under a square root function. Other examples would be an expression raised to a power, an expression in the bottom of a fraction, an expression in the bottom of a fraction under a square root, and finally an expression in the bottom of a fraction raised to a power. So these are all examples on how you could go about finding u. So here I have example number 1, the integral of 2x times cosine of x squared plus 1 dx. So for step 1, it's setting u equal to x squared plus 1, and then for step 2, you want to find du so we can understand that d dx of x squared plus 1, or the derivative of this function with respect to x, is 2x. And then we can move the dx up to the other side, and we get d of x squared plus 1 equals 2x dx. And then we can change x squared plus 1 to u, because that's what we set u equal to in our first step. And then we get du equals 2x dx. And then step 3, we get the integral of cosine u du. And now that we have a differential du that agrees with the rest of the integrand, we are ready to integrate. And the integral of cosine u du is sine u plus c. And now that integration is complete, we can return u back to its original form and get a final answer of sine of x squared plus 1 plus c. And I wanted to point out that this plus c is here because this is an indefinite integral, which means it has no limit, and the plus c represents that. Next, I will be talking about definite integrals. And the difference between definite and indefinite integrals is that indefinite has no limit, while definite integrals do. And this is the U substitution form for definite integrals. And it's basically the same as the form for indefinite integrals, except that now we have boundaries, which is represented by the A and the B. Here we have example 2. Uh, the integral from 0 to 4 of square root of 2x plus 1 dx. And step 1, we do the same as we did for the indefinite integral, which was set u equal to 2x plus 1. And then step 2, we find du. So du equals 2x, equals 2 dx, which is the derivative of 2x plus 1. And then we multiply both sides by 1/2, and we get dx equals 1/2 du. And then for step 3, before changing our integral into u variables, we also want to change our boundaries to u because they were originally written in x terms. So to do that, we would set x equal to 0 and then plug in 0 to u equals 2x plus 1. So 2 times 0 plus 1 equals 1. And then we'd set x equal to 4 and we plug that into the u equals 2x plus 1. So 2 times 4 plus 1 equals 9. And then for step 4, we can finally rewrite our integral into all u variables along with our new boundaries that are now written in u terms. And if you continue the solving the integral, you should get 26 over 3. And then finally here I have my 3-question quiz. And so the first question is, what is the u substitution? The second question is, what is one thing you should look for when finding u? And the last question is, which integral has no limits of integration? And the answers are number 1, the integral f of g of x times g prime of x dx. Number 2, the longer x expression that appears in the integral and the expression that's inside some other function. And number 3, it's the indefinite integral. Thank you for watching, and I hope this PowerPoint helped on understanding u substitution.